Alright guys, this is how to solve systems by graphing. The way that you can tell that you want to solve a system by graphing is, one, did your teacher tell you that you have to solve the system by graphing? But two, you also want to know if you have to, you can also tell that graphing would be the preferred method for solving a system if it's presented to you in y equals mx plus b. And so what we are looking at here is a whole bunch of systems of equations that are being presented to us in y equals mx plus b, because that is a very easy form of an equation to graph. It's easy to find the slope and the y-intercept. So the steps for solving a system by graphing is to graph both lines using either the slope or y-intercept or the two intercepts. So if you had something in standard form and wanted to use the two intercepts, the x and y-intercept, like I showed you on the graphing video, if you don't know what I'm talking about here, go back and watch the graphing lines video, because I talk about using the two intercepts to graph a line. So you can graph the lines, and then you find the point where the lines cross, where the lines intersect, is the technical term for it. All right, so we're going to look at these four examples. Please, if you want to, go ahead and watch my first example, but then pause the video and try to do each problem before I go through it, so that you are actually getting some experience working through the problems. Please try to do that so that you can, try it on your own, see if you got it right, and then watch the video to check your answer or to find your mistake. Please don't just watch the video and write down the answers. Please actually pause it and try the problems on your own. So I'm going to graph these two lines, y equals 5x plus 2. And here the slope is 5 over 1, and the y-intercept is 0, 2. And so what I do is I go up to 2 on the y-axis and draw a dot. My slope is 5 over 1, and that means I'm going to go up 5 and right 1. And so I'll count up 1, 2, 3, 4, 5, and right 1. And then, guys, there is no more room to keep going up on this graph, and so I'm going to reverse the slope and plot the other point. So I went up 5 and right 1. To reverse the slope, I would go down 1, 2, 3, 4, 5, and left 1. So I do the opposite of both, the up and the right, so I go down and left. And this line right here looks like this, maybe a little less wavy. Again, you guys are using straight edges to draw your lines, so make sure they're nice and pretty and straight. All right, and then I'm going to graph the other line, which is y equals 3x. Here, the slope is 3 over 1, which is up 3 and right 1, and the y-intercept there isn't one, right? It's missing. But what number do we use to talk about y-intercepts if there isn't one, if something is just gone? And the number that we use is 0. So the y-intercept for this is 0, 0. And so I draw that y-intercept at 0, 0, and I go up 1, 2, 3, and over 1, and up 1, 2, 3, and over 1. And I'm also going to go down and to the left just to graph a couple more points to guide me. So I go down 1, 2, 3, and over 1. And what do you know? That's a point that these two lines share. So I'm going to connect these dots as best that I can on this. There we go, on this computer projector thing. And right here, this is our solution. Now, it is not enough just to say, oh, look, they cross. We actually have to identify the solution. So our solution here is the point -1, -1, 2, 3. It's the point -1, -3. That's our solution. Okay. So there's your example, guys. Now please pause the video and try the other problems on your own, and then come back and check your answers when you're done. So here's y equals negative 3x minus 13, and y equals negative 1/2 x plus 2. And I'm going to graph those. The first equation, y equals negative 3x minus 13. The slope for this equation is negative 3 over 1, which means it's down 3 and right 1. And the y-intercept is 0, negative 13. Now, I've noticed that 0, negative 13 is not on my grid. This grid goes to 1, 2, 3, 4, 5, 6, 7, and negative 13 is going to be pretty far down here. But you know what? We can work with that. We can approximate. So we'll just say like 1, 2, 3. I got to go down another 6, 4, 5, 6-ish. Oh, so I'm on the other grid. We'll make it work, guys. And my slope is down 3 and right 1. So that would be still on the other grid. You know what? We're just going to instead reverse the slope. So we're going to go up 1, 2, 3, and left 1. And I'm using the grid from right here as my guide. And then up 1, 2, 3, and left 1. 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 And now I have quite a few points. I'm going to go ahead and come down here and erase these points down here, just because I don't want them to get in the way of that fourth problem. Okay, and now what I'm going to do is I'm going to connect those points with a line. So this line goes down through these points. Oh, now I got a little wobbly. Your lines will not be wobbly because you're drawing on paper and you have the ability to use a straight edge of some sort. A ruler, a notebook, a stack of Post-its, something to connect the dots on your grids. All right, I'm going to look at my other line, the y equals negative 1/2 x plus 2. Here the slope is negative 1/2, and the y-intercept is 0, 2. The slope, the negative 1 over 2, means we go down 1 and right 2. My y-intercept is right here at positive 2, so I'm going to graph that, and then I'm going to go down 1 and right 1, 2. Down 1 and right 1, 2. And I notice that I'm not getting any closer to this line over here. So I'm going to stop counting down 1 and right 2, and I'm going to reverse the slope, which is something we can do. Again, I go the opposite of both of those. So instead of down 1, I'm going to go up 1. And instead of right 2, I'm going to go left 2. So up 1 and left 2. Up 1 and left 2. And very conveniently for us, this point right here is shared by both lines. And that is very convenient because with my wavy lines, there's no telling if I would actually be able to find the intersection point. And that's why it's really important. See, I didn't even make it through. That's why it's really important that you guys use rulers and straight edges. Is because if you've got wavy lines like mine, you're going to think that it crosses here. But we know it crosses right here because I plotted those points. And so this is our solution. Okay. And it's not good enough to just draw the graph. You've got to tell me what the solution is too. So the solution to this is the point negative 6. And it's up 1, 2, 3, 4, 5. Negative 6, 5. That's where those lines cross. All right, moving on to number 3. I'm going to graph these lines. So I've got y equals 1 over 5x minus 3. The slope here is 1 over 5, which is up 1 and right 5. And the y-intercept is 0, negative 3. And so if I plot the y-intercept at 0, negative 3, it's right here. And then my slope is positive 1/5, so I go up 1 and to the right 1, 2, 3, 4, 5. I can't draw any more points on this grid, so what I'm going to do is, again, reverse the slope. So I'm going to go down 1 and 1, 2, 3, 4, 5. So completely reverse the slope. And then I'm going to connect those dots. Ooh, sorry guys, it's really hard to draw straight lines on this thing. Okay, but you're drawing straight lines because you have a straight edge and a piece of paper. My second line is y equals 1/5 x plus 3, and the slope is 1 over 5. And that's the same as the slope right here. It's up 1 and right 5. The y-intercept is 0, positive 3. What does that mean? 1, 2, 3. If you answered, they're parallel to my what does that mean, you're right. So the slope is positive 1/5. That's up 1 over 1, 2, 3, 4, 5. And down 1 over 1, 2, 3, 4, 5, right? And so these lines are, in fact, parallel to each other. Look at that. And so what does that mean in terms of a solution? Well, a solution is where the lines cross. And since these are parallel lines, they will never cross. And so we know that that means that there is no solution. No solution. All right, moving on to number 4. I'm looking at this and I'm noticing that I have the same slope and the same y-intercept for both of these lines. What does that mean? What does it mean? So guys, if both of these lines have the same slope and the same y-intercept, I'm only going to identify the slope and y-intercept once. This is negative 2x plus 7. The slope is negative 2 over 1, and the y-intercept is 0, 7. And so those lines are exactly the same. I'm going to go up to 7 and draw a point at my y-intercept. Then I'm going to go down 2 and to the right 1, down 2 and to the right 1, down 2 and to the right 1, down 2 and to the right 1. And here's my line. And that's only one line. I only graphed one line. But if I graphed the second line, it would be exactly on top of this one line. And what does that mean? What does that mean? Well, this system had no solution because the lines never crossed. But in this system, the lines lie one right on top of the other. And what that means is that we have an infinite number of solutions. An infinite number of solutions. And so systems that have infinite solutions look like this. They're just one line. All right, kids. Systems that have one solution that you're going to give me a point for look like these two systems where there is a point where the two lines cross and you can find it. Systems with no solution are parallel lines, like this system right here. And systems with one solution, or I'm sorry, an infinite number of solutions, are systems where you just have one line that you graph because the equations were exactly the same.